All right. Oh, there we go. Okay. Hello, everybody. Yeah, I'm Noah. I'm going to be talking about Juice in 2019 because it is 2019 and you're still not using ScreenShake. Yeah, just a quick about myself. I've been making games for a while. A number of them I think are pretty juicy. I am one of 3 of Aesthetician Labs. It's a studio that started about a year ago. We made a game called Crazy Plates. And there's my Twitter. Yeah, I think juice is pretty important, but I think first we should define what juice is. According to Martin Johansson, who I'm probably murdering his name, and he's going to come up a lot for the future, so sorry in advance. But juice is things that wobble, squirt, bounce around, or make cute little noises. They give the game kind of a feel, or kind of a tactic or tactile sensation to it, or like weight. And they're usually audio or visual based, but they don't have to be. They give the player more feedback for their input. So like in this GIF, you can see, the things shake a little bit when there's an impact and there's particle effects, and obviously you can't hear a GIF. Juice is something that's super important, especially to do early in a game, because when you're playtesting your game, you'll get less aesthetic-focused feedback and more gameplay-focused, more mechanically focused, and you actually get to see the things that you're looking to test. Players and designers, whether we want to admit it or not, have a hard time separating feel and mechanical issues. So if your game looks, sounds, or feels bad, but the mechanics are solid, you're going to think the game is still bad. And in general, it kind of is. Juice is the aesthetic in Aesthetician Labs. So if that doesn't tell you anything, we think it's kind of important. We like to focus on these aesthetics first. And juice doesn't always have to be like perfectly optimized, well put together code. And often it's not at all. It's just like thrown in and it's like, this will work for now. It's nice to build out a tool set of things that you can reuse, like a camera shake script that you just slap on whatever. But at the end of the day, you should do whatever makes your game look and feel the best and worry about optimization later. That's just like a broad, I think that's a great way to approach development. Get the feel first before you get trapped in like a programmer trap of making something perfect. Some games that have some really great juice. Hold Down by Martin or Grapefruit is a great example. Hold Down has a lot of really nice, it's almost like very squishy or like jelly-like the way it feels when you play it. There's really great sounds, again, you can't hear. They're very round sounds. The camera shake is not like a standard hard shake, but it's more of a wobble, which kind of adds to that jelly feel. And there's a bunch of other things like these flashing when they get hit, so on and so forth. Crazy Plates, not to toot my own horn too much, but Crazy Plates, we focused a lot on juice as well. You can see particles, screen shake. We actually, in Crazy Plates, borrow a similar style of camera shake as Hold Down, and I can talk about that later. But there's a lot of particle effects. This is actually an early development GIF, so it's not even the final thing. Also, Towerfall, kind of getting off the mobile realm. This is another game with just amazing juice in it. There's lots of particle effects, lots of squish and stretch type stuff. I like also they have hit frames, so you can see when somebody gets killed. There's like a quick break, and that just feels so nice. And then Ridiculous Fishing by Vlambeer. Lots of particle effects, lots of screen shake. Really pretty game. So yeah, what we're going to do is most of this demonstration, or this talk, is going to be a demonstration I'm going to show you, I made a clone of Breakout, and I'm going to kind of unroll a bunch of different juice layers on it and show you kind of how those impact the game. It's built in Unity, but most of these tips are engine agnostic. The point is more the actual application than how we get there. And there are a couple of Unity specific things, and I'll try to point them out as we go. You can, after this talk, I'll put the slides up and you can get the source on GitHub. So let's go ahead. Oh gosh, so many things. Okay. So we're gonna start, not here. This is sus Unity. You're recompiling. Okay. So we're going to start. So this is just the breakout clone by itself. We'll go ahead and make this a little bit easier to see here. We'll move this over here. Make this a little bit bigger. So yeah, this is just breakout. So you can move the mouse and paddle around and break some blocks. Pretty standard stuff. Not a whole lot here. So what we can do though is kind of the first thing that you can do in Juice, and is pretty simple, is just kind of think about color a little bit and maybe add a little bit of color to your game. So I mean, immediately I am pulling a little bit from BC's color theory workshop, but basically, like in this case, I literally just picked a color. I think I started at this orange for the blocks, and I said, oh, that looks good. The saturation's a nice level. And then I just kind of went around the hue slider and then picked the rest of my colors, other than the background is a little bit darker. So starting with just one color and then staying within the hue band, or staying in, like, I think BCU said the rule is basically lock everything but one slider and then change that one slider to make a color palette, really basic one. And that's basically all I did for this. One thing I thought might also be cool once I did this is the great thing about the Juice kind of process, is you start somewhere and then you go, oh, well, it'd be cool if I did this too. And again, that can be a trap, so make sure you're staying within your timelines. This talk got a little out of scope, but I thought it'd be cool if all the blocks changed hue as like in a gradient as they went down. So I made by row they get a color. And this is a simple, because I'm generating the blocks at runtime, this is a pretty simple just move the hue by, I think, like 5 degrees every row, and then you get a gradient. And this already adds a whole lot. Like, this game already feels a little bit better because it's got a little bit of color compared to just black and white. There's not much here. Okay, so we've got color. That's pretty cool. The next cool thing that you can add is animations, just in general. You can use simple animations where you just move a percentage of a way to a target position. Maybe say with the paddle following the mouse, we have it slow down or follow the mouse but on a delay. And what function I'm using here is actually just an equation. I can pull it. Go to the paddle here. Oh. So the equation I'm using is relatively simple. That's not it. There we go. So this is taken from Martin and Petri's talk, Juice It or Lose It, which if you go watch, it's in the references. You'll see how much I totally copied a lot of their stuff. This is heavily inspired by their talk. But he gives this formula, which is just x plus equal target minus x times a percentage. And so it just says every frame move this percentage towards the destination, like the target. And that's all I'm using here, except I set an arbitrary. In Unity, I expose the target. So now I can go into the paddle, right, and say, let's maybe make it slower. And so now it takes a little bit longer to follow the mouse. Or you could make it snappier, and now it's right on the mouse, right? And so giving yourself, especially in tools where you have a graphical user interface to adjust these values, building your scripts so that they are as reusable as possible and as adjustable as possible is really nice, because then you can just tweak things in the editor without having to worry about recompiling. Cool, so we've got this little bit of lerp. Let's bring it back down just a little bit. Well, we can go. Okay, so we've got this nice lerp. Now, let's go ahead and add a little bit of squash and stretch as well. So now, when the paddle moves to follow the mouse, it actually squashes a bit. What we're doing here is I'm just taking, and again, this is pulling directly from the Juice It or Lose It talk, but I'm just taking the distance between the target and the current position, so where it wants to be versus where it is, lop that in half just to set the scale, because Unity origins are from the center, and set the x scale to that distance. And then the y scale, I make the inverse of the x scale, so 1 over x, to preserve the volume of the paddle. Because a rule with squash and stretch in animation is to preserve the visual volume or surface area of the shape. Otherwise, it looks a little weird. So this shape is staying the same volume, but it squashes to follow the mouse, and it feels like it's kind of like jerking to get across the screen to the mouse, which is cool. Slidery feels pretty good. We're going to tighten up the pedal a little bit because that's a little extreme. I'll give it a little bit more. There we go. The other nice effect of this is I'm actually changing the collider when I delay the paddle, and that can kind of affect your game. And when I stretch like this, the collider stays right below the mouse. So you never have a situation where even if I go all the way down, even if I set it all the way to 1% follow, it's still relatively following the mouse, right? So the players don't feel as cheated by your nice animations. Okay. Some other things you can do with animation, you can use easings, which are functions that are predefined. You can Google, I actually provide one in the resources, but there's a set of easing functions that basically just move from a target to or from a position to a target over time, and they have a number of different animations that they follow. I actually have, I'll pull it up, go to the references real quick. There's a Unity easings script on GitHub. There's a really nice gist, and it provides all of the easing functions so you don't have to write them yourself. And we can go and look at easings.net and see some of them. So basically you have like your kind of like standard like just a sine, so it's just like slowly ramp up, slowly ramp down. Basically just smoothen the animation, but then you can also get some crazy ones where you get like elastic effects or a bounce effect and stuff like that. These are really nice to just basically drop right into your project where you just need a little bit of animation, but you don't want to have to do too much work for it. If you're not going to just use the delay move, which is what I use for most of this project. So now let's go ahead and get some more blocks on here. We're going to have the ball rotate to follow its velocity. This is a pretty simple one. And we're also going to have the ball squash and stretch when it hits stuff. So now it gives itself a little bit of a squish. I didn't actually preserve the volume here. I turned it down quite a bit because if we go to the ball, where is it? There it is. And we turn the stretch intensity back up. If we go to like full volume preservation, it gets pretty weird. It looks a little gross. So let's bring it down a bit, and then it feels a little bit better. So again, tweening isn't always about, or juice isn't always about making something exactly perfect or right. It's just about what feels good. Cool. So let's also, when we bring in the blocks, let's have them ease in. And it's best if I reset it. So now they animate in. And this, I'm using an easing function. So I'm actually using, let's see here. I think I'm using ease out elastic. So it does a little bump over and then back. So when they animate in, and they animate in on a slight delay, which I think feels really good too, you get kind of like this scan line load in and kind of bouncy effect, which feels really nice. So now the next thing that you can add to a game to make it feel really good is shake in general. And this is a kind of animation. So for example, we can have the blocks shake whenever the ball hits something. And now immediately the ball feels way weightier, right? It's not the most subtle, but it gives this kind of like jelly feel to the game, and also gives the ball a lot more mass, because without it, it just feels like it's just kind of bouncing around, right? Once you add just a little bit of shake just to the blocks, you feel like there's a little bit more weight. What's up?
What does that shake function look like?
What does the shake function look like?
Because I've tried adding shake to objects for like years, and I've never found one that's like before.
Sure. Yeah, so this one, it is a variation on the same just follow a specific percentage, except I have a shake amplitude, and I multiply that against a sine function. So I take a sine curve, I multiply that by an amplitude, I move along the sine over time, and that's just like a speed, right? And then I decay the amplitude of the shake using the lerp to target function. And so it's a stacked, like one is just shaking it, but if we just did that at an amplitude and then like linear interpolated it down instead of like smoothed it down, you would see it a lot more clearly than if it quickly drops, right? And then you can tune that decay. So for example, we could go in, and this is kind of annoying to change, but we can. Let's go ahead and reset this here. Oh, I did actually put it on the game manager. Thank heck. Yeah, block shake. So if we turn up the intensity on this a little bit more, you can get pretty crazy. And we can turn way up the decay too. So now it goes way fast. It decays way faster. And if we bring it way down, then they just shake forever. We'll bring it back to where it was. Yeah. So now that we've got a little bit of shake, we can bring in the next thing, which is, teasing a little early. As Martin puts it, extremely powerful and should be used with great caution because it's extremely powerful. But it's the classic camera shake or screen shake, right? And so this one, I'm actually shaking it with the ball's velocity, so it shakes in the direction that the ball hit a wall, or hit anything. So it really feels like the ball is kind of punching things around, which is nice. So now, along with the shake from the blocks, you get this whole screen moving effect, which is really nice, I think. And again, you can tween, or you can adjust this however you want. You can bring down the intensity and make it a little bit more subtle. You can make it less subtle. You can make it extremely less subtle. Really, it's up to you. But this is where you have to be careful. You can get a little crazy. And you don't want to give your players motion sickness, at least not too much. So we'll keep it a little more subtle than that. This feels good. So we can also have the camera kind of follow the ball a little bit. And this effect is one of the more subtle ones in this example. But for maybe another game, having kind of even though you might have a static screen, having your camera kind of dynamically adjust to shift around and follow what's happening on the screen can be nice. So in this case, we're just going to have the camera slightly follow the ball here. It's pretty subtle, but it just kind of moves around to adjust to where the ball is on screen and follow it around a little bit. And so that adds a little more dynamicity to the whole thing. We won't talk about that collision down there. Cool. So now we've got shake, we've got animations, we've got a little bit of lerping. It all feels pretty good. Compared to what it was before, we can kind of turn everything off here. We've made pretty good progress, but we can go further. Bring it back up. Okay. So the next big thing that you can do to juice a game up real fast is just add particles. And in Unity, conveniently, this is super easy. Unity has a built-in particle system that more or less, especially for juice purposes, will do what you need to do and is really powerful as far as control. So first thing we can do is like a classic dust effect. So whenever the ball hits something, just leaves a little bit of dust. And these are just squares that are random size. They have a little bit of velocity that's off of the direction that it's the opposite of the direction the ball hit. And they just scale down in size over their lifetime. And they are a random lifetime between, I think, like 0.5 and 0.8 seconds or something like that. So you get like a quick few bursts of dust that then just shrink into nothing, and then they're gone. And that's a really nice trick with particles, is to just shrink them away or fade them away. You don't want particles just to blink out on screen because that doesn't feel so good, but having them just kind of like shrink out of existence feels really choice. Next, we can add some particles when the ball hits a block. So let's get a couple in here. Okay, so now the blocks explode into a lovely burst of particles, which feels pretty good, but it's kind of weird that they're just kind of falling all over the screen. And luckily in Unity, we have the beautiful ability to have particles collide with other colliders. So let's just go ahead and turn that on. So now the particles actually collide with the other blocks, which feels pretty good. Feels a little bit more in tune with the world now. See if we can get a nice big one. Cheat a little bit to get it. There we go. Oh yeah. And again, those blocks are just shrinking to nothing. And I'm also I'm emitting a random number of them between, I think, 15 and 20, just for some variation. And the scales are a little bit random as well. But what if we had the blocks particles fly away from the velocity of the ball? So now the ball hits it and kind of throws the particles away from it, which feels, again, really good and adds more and more power to that ball, right? So now it's really tearing things up in here, and that feels pretty great. Next is audio. So audio is a huge component of a game. We've been focusing only on visual right now, and this game still has no sound. And while it looks like it's really cool, there's a lot of elements where it's like you can hear what you want to hear here, but like there's no sound coming from the game in reality. So we should probably add some sounds. And the first thing we're going to do, because the ball feels so weighty, is add some sound effects for the ball. So every time the ball hits something, just give it a little punch. And already immediately, again, it is reinforced by all the other layers of juice, and it adds another layer of just good feel and punch to the game. I made these sound effects that I'm going to be using all in a tool called BFXer. It's a really cool, like kind of chiptune style sound effect generator. It's free. It's available. It's in my resources slide if you haven't heard of it before. It's super cool, and I've used it for a number of game jams. A lot of the Crazy Plate sound effects were done in BFXer for the original game jam, and they just never changed because they were good enough. And I whipped together all the sound effects for this in like 15 minutes. So now let's go ahead and add a sound effect when the ball hits the paddle. Just a little bit of something for the rebound. And then let's add one for the blocks. And again, combining with that kind of like shatter that's happening, I went for kind of a white and shatter sound effect. Oh, there we go. That was a nice hit. That felt really good. Classic. There we go. So now, I mean, this even compared to this, right? Just the difference between 3 sound effects and no sound effects is huge, right? Another trick that is super cheap is to just slightly randomize the pitch of some sound effects that you're playing within a certain range. So we're going to randomize the ball hitting and like any surface, and also the blocks breaking. And so now it's subtle, but basically you get this effect where repeated hits don't sound as repetitive. We're not randomizing the paddle hit effect, because ideally if this were real breakout, you wouldn't be able to bounce it behind your paddle. So like I said, subtle, but it adds a little bit of something extra. A little bit more juiciness. Oh, those are nice. All right. And finally, a great extra layer we can add is music. So we'll get, hopefully, oh, I broke it. That's okay. Actually surprised it's still playing. It's here. Well, what we'll do here. Luckily, I put a scene in the oven, and we can just pull that right out, and this one should work. There we go. This is everything on. Let me turn it down a little bit. This is just a song I found on Kevin McLeod's website in Compotech. So it's a Creative Commons attribution license song. And then he also has the ability, if you want to, I think it's like $30, you can license any of his songs for single use in a game. So for example, for Udder, we just pulled a good bluegrassy banjo song from his website. And then we're like, well, we want to keep this, but for the platform we released on, we can't have credits. So we'll just license the song and then we're done, right? It's that simple. So we were able to keep what we originally put in because we didn't have to get anything new. It worked. And same for this. This song feels good enough for this style of game. It just adds a little bit of extra kind of playfulness to the game. And music is where you can really pull in a lot of mood for your game. So for this, I was gunning for a more like playful with all these like bright colors and explosions everywhere. But you could go for maybe if you were making a horror game, something scarier, or something that's a little more high energy, you could go for driving energy over playfulness, right? This is where you can kind of define what the player's experience is through audio cues. So this kind of covers, if you watch or have watched Juice It or Lose It, Martin's talk, this is kind of where they get up to. I want to talk about maybe some things that you can do on top of these basic things, maybe what we'd call some intermediate level juicing, but some of them are super easy. So one of my favorites, absolute favorites, is the classic pixel filter. Crazy Plates leaned very heavily on this, and you can do it, if you're using Unity, you can just do it to any game. You can just turn it on in probably less than 30 minutes of work. My trick for using a pixel filter is you take a render texture, so you have your camera render out to a separate texture that is a fixed resolution. You set that texture to not do any kind of blending when it scales, so it doesn't do like bilinear scaling. It's just point scaling, so it preserves each pixel. And then you just slap that render texture in the UI right on the screen as a raw image, right on top of the whole game. And then you're done, it's right there. One thing you have to be careful about, especially in a game like this where I'm using the mouse for the paddle, is the camera is now fixed to that smaller resolution, and your mouse events will be, if you're getting the mouse position from a camera that is using the render texture, the position will be relative to the render texture size, not to the full screen size. You can fix this by just adding another camera to the screen that doesn't draw anything. You can set, if we open it, the second camera, the mouse camera here. I just set the, well, you could set the culling mask to nothing, and you ideally turn off everything, and then it's that simple. Then everything that you use for position on screen, you just route through this camera instead of the render texture camera. There's a couple other approaches you could take. In Crazy Plates, we actually, I think, use 3 cameras, each independently for different things. I think there's one specific UI camera, and then there's like an in-game UI layer. It's a whole thing. But a very simple way just to drag and drop it in, basically, is just add another camera, tell it to render nothing, put it right at the same place as your normal camera, even make one or the other a child. That works too. Add a single image to your UI that stretches to fill the whole screen. And then I have a script in here that basically just creates a render texture that's sized for the screen based on your target vertical resolution. So I have 128 tall. And if I just hit run here, there you go. It's a pixel art game now. And everything else is the same. In the scene, we've still got those dust effects. We've still got the particles from the blocks. Some things you do have to be careful about. You'll get some interesting artifacting. You can kind of see it when it shakes. Just because of the rounding that has to happen to scale your image. At lower resolutions, this is a little more noticeable than higher. This is something that we actually leaned into a little bit with Crazy Plates, though. We added some intentionally grainy textures that created noise whenever they moved. But if we go up to like 256 now, so this almost is hard to distinguish from the original game, but it adds a little bit of a pixely crunch to the whole thing, which is nice. And you can use any old value here. You do have to restart, at least with my script, you do have to restart it because it builds the render texture at the start, and Unity doesn't like it when you change render texture sizes at runtime. There you go. So you can use any arbitrary value. Especially if you're like trying to make maybe like a PS2 era style game, you can use this to get a really crunchy feeling aliasing on all of your models of the scene. Because it's 2019 and HD games are boring. And it's 2019 and we really need to revive PS2 era aesthetics. Cool. So that's the really simple to implement. Again, you can see this if you want to dig into the scene and have a look at actually how it works under the hood on GitHub. That'll be linked in the slides. That's a quick one. There's also a really cool camera shake algorithm you can use that's different from the traditional. So the traditional shake is basically have a point. Actually, I can pull up the code. So your classic camera shake is, no, this is not. There we go. So this is your classic camera shake, is take, and I'm using the direction from the ball like I said, but you basically set an offset for the camera's position based on the sine wave that I was using for the bounce for the blocks. A sine wave with the phase over time, and then an intensity, and then you just add that to your camera's position. Make sure that you store the original position though, because you don't want the camera to like move, and then you shake it again and offset it again. That's like a common gotcha when you're first implementing camera shake, is you just kind of shake away. Right. So I usually just store the original position, and I actually have the camera doing it itself, so it stores its original position and then adds, if I can find it, there's a lot going on in here, adds the shake offset to its final position at the end. So it's rebuilding its position every frame instead of adding on to its original position. But that way or adding on to its frame position. That way we're preserving the original center position. If you want it moving, like in Crazy Plates, you just know what your target pause is, and then you work off of that instead of your like original position. So that's the traditional though, is just kind of move the camera offset of its root point. A cool algorithm that was, I think, developed, at least first talked about that I know of by, oh, where'd it go? There it is. No, we don't want that. Martin again, Grapefruit, is how he does the camera shake and hold down. You know how I mentioned that's a little bit wobbly and it feels a little bit more like jelly than it does like shaky. So if we can look, you get, in Ridiculous Fishing, they're using standard screen shake, so you just kind of get it shaking all over the place. Whereas in hold down, you get this kind of like wobble feeling. It feels like you're kind of looking around, right? That's because what he's actually doing is he has a perspective camera that looks at a point that's behind the whole game plane. The game is a bit in 3D. Mostly just the background is a little bit further back. And actually, I think he pops the UI up too. And so what you get is you feel like you're actually looking down through something, and you can kind of peek around stuff when you hit something. And it just feels so good. So that's what we did for Crazy Plates. Crazy Plates uses kind of a modified version of that. It actually tilts the whole camera a little bit instead of looking, but it's the same thing. It tilts, so you see the tops of the building shake more than the base, and so it's more like you're shaking the city than you're shaking yourself. And we also tilt the UI sideways, so you can combine different layers of juice to create a screen shake effect. So we tilt the UI to the side that you hit, and then we also shake the camera by rotating it a bit around a central point that's behind the game plane. So to do that, in this instance, what I did is I took the point behind the plane. Let's see, we'll pull back up this picture so we'll illustrate it well enough. The point behind the game, the camera is watching that point and moves to shift a little bit to kind of like adjust as the point moves. But ultimately what it's doing is it's looking at that point, and that point shakes with a traditional screen shake. I'm actually just using the original screen shake algorithm, but shaking that point instead of shaking the camera. And so what happens is the camera kind of tilts and shifts to look. Will I see a hand, Dakota?
So in Crazy Places, is that point that it's looking at, is that attached to the car?
The point that it's looking at in, right, it follows the car. The camera in Crazy Plates actually goes a bit ahead of the car, just very slightly. And it also does a little bit of movement with the velocity of the car. But it's actually not even looking at the car. It's just a point directly behind, like directly in front of the camera, right? So if you just projected however many units in front of the camera, there's a point, an imaginary point there that it's rotating around. All of that assembly moves to follow the car. The way I did it in Crazy Plates is actually I have the camera on a game object, then pulled back from that root game object, and I just rotate that game object, and then that game object follows the car. And that's how I do for a lot of my games. Instead of like trying to do vector and quaternion math, I just put a nice arrangement of transforms in Unity so that I have like yaw, pitch, and roll control of like what would be like a artificial camera arm, and then you have a lot more control without having to do the math. Because Juice should be quick, not perfect. So in the what I've dubbed the Johansson, like I said, he's going to come up again, shake, because he didn't give it a name, so somebody's gotta. Just do the normal shake. I'm literally just using the other shake class and using its offset. So it shakes the camera negative. It moves the camera in the opposite direction of where the point is moving, so the camera kind of rotates with the point. And then we also, this is a little bit of math to get, or this is just a function call in Unity, but this is a function to get the camera to look at that point, right? And then if we look at the implementation, we store our original offset or original rotation, and then we multiply it by the shake rotation offset and quaternion multiplication. The order matters, so you have to do the left-hand side is what's being applied to the right-hand side usually. So in this case, it's similar to just adding the position, the original position to the offset. It's just a little bit more complicated. And then so that effect, although it's not implemented in a way that feels super great for this project, looks something a little bit like this. So we have our background. If we go into the scene real quick, we have our background kind of a bit away from the camera. The camera's here, and the point it's looking at is back here, so behind the background. And so what you get, even though the only element that's different on a different plane is the background, is you get even just a little bit more of that wiggle feel, right? And I turned it up a bit for this, but we can tweak this all we want. We can bring the decay up a little. Let's bring it down a little bit, but bring the speed down. There, so now we get something that feels a little bit more like open. And it just adds just like a subtle dynamicity to the whole scene that is one step up above just a traditional camera shake, right? So yeah, these are some tips that you can apply for your game to add more juice to it. There's a bunch more other options that you can take. There's some great other talks. Like I said, Juice It or Lose It, which mostly covers what I covered here. And if you watch it, you'll realize that I'm a total ripoff. There's also JW from Vlambeer, who I think in 2019 right now, the best people doing juicy stuff is Vlambeer and Grapefruit. So, but he does a talk also called, I'm going to go to my resources to look at it. His talk is called The Art of Screen Shake, right? And he dives in a little bit more to his philosophy of feel and why feel is a bad word, a little bit why he thinks feel is a bad word, but his philosophy of feedback for players in games. And so that goes into more of the theory side of things, which is pretty cool. And he does a platformer demo. So if you're more interested in like a 2D shooter platformer style thing and want to see a different application, his is really cool. And he talks about some of the tips that Vlambeer uses for their stuff. So yeah, some takeaways. Juice is great for early prototypes, and it is not just for your final polish push. It should be done early because it'll help you get better feedback. It'll help you make you feel better about your game while you work on it. And like keeping up that morale, looking at a good game, like looking at, looking at something like this, when you're working on a problem, maybe you're fixing a bug and you have to deal with this, versus looking at something like this when you have to fix a bug in Collision and it's been 12 hours and it's still not working, right? It's a completely different development experience. Something that kind of pulled me along in Crazy Plates for a lot of the development was, I think the ball is actually still squishing and stretching. Something that pulled me along in the development cycle of Crazy Plates sometimes was the fact that I could just sit back and play it and have fun for a bit, right? And it felt good. And if you have a game like this, like, okay, maybe it does feel okay, but compared to something like the, pixel art, super juicy game, it's a different experience, right? And it just makes you feel better. So Juice is good both for feedback from players, but also for developer well-being. Don't forget about Jiffle. Juice first, optimize later. It's okay just to put in garbage code. A lot of what I'm going to be sharing with you is kind of bad code. That's okay. I threw this demo together in the past 36 hours, and it works. And it gets the point across. That's the whole idea with games, right? If you need to optimize, do. Don't do it until you need to, though. You don't have to optimize early. It's a programmer trap. Juice can be a great creative jumping off point that helps you find your kind of game's voice, right? So maybe you put something in, you're like, that doesn't feel like it clicks with the rest of the mechanics. Or maybe you put something in and you say, wow, I never considered that this would click with the game's mechanics. Just in the process of making this breakout clone, I was like, oh, I'll add these colors. And those colors complemented well kind of the bounciness, and I thought, well, this is all very playful so far. Let's lean into that a little bit more, make everything break, make everything more weighty, and then let's add some sound effects that reinforce that. And so I found a game that was weighty and playful was kind of the primary two things. And then when the arcadey music came in, I was like, pixel filter makes sense. So you can kind of find a path, maybe if you've just got a prototype and you're not sure where you're going with it yet, or you at least start with something and maybe you don't want that, right? And Juice is something that you can just have fun with. It's a great thing if you're on, you just did a big refactor and it really sucked, or you're in the middle of a big refactor and you want to take a break. You can always just pop in a little bit of something nice and juicy or fun somewhere there. This has been a super fun project to put together because every change feels substantial. Every single thing you see on the screen right after you do it. And then tweaking those values feels really good too. Finding that perfect, right where you're like, yeah, that's it. That's the feel I'm going for, is awesome. And it makes you feel, even if you are primarily a programmer or primarily a designer or primarily an artist, it's something that pretty much anyone can do, at least tweaking the values. And implementing is somewhat simple as well. You can find a lot of the scripts that or the algorithms that I wrote, you can just find them online. But it's always a way to make you feel like you have some creative power in your game, which is super cool. Like I said, some references. Both these talks are really killer, and I recommend giving them a watch. I think Juice It or Lose It's pretty short. Art of Screen Shake, I think it's 50 minutes, so both not too bad. This is the tweet that I referenced, and BFXer and Incompetech are both great resources. There's also some other good Creative Commons audio resources. I also use Freesound a lot, freesound.org. A lot of Crazy Plate stuff came from Freesound as well. So yeah, that's my talk. That's Juice in 2019. What's up, BC?
Going back to the easing in of the blocks,
Mm-hmm.
You mentioned the scan line that kind of goes across.
Yeah.
Is that just kind of like a happy accident of the way they're all lined up and how they happen to animate too?
Kind of. So the question was, is the scanline effect a kind of happy accident of how they were already being lined up and generated? Kind of. It was more intentional than that, though. I wanted them to come in on a delay. And the way I did it, I could have had them all come in on the same delay or pop in on random delays, right? Those are two options or routes I could have taken. But what I actually chose to do, and I closed Game Manager, that's what went away. What I actually chose to do is, when I make a new block, I set the delay for that block's animate in to the current number of blocks plus 0.01 seconds. So each new block has an additional 0.01 second of delay. And so by the last 40th block or whatever, that's nearly half a second of delay, and then all of them just kind of scan in. And I actually had to change, I was doing this by columns then rows, and I had to change that so it didn't go vertically, it went horizontally. Any other questions, thoughts? Dakota?
So you mentioned
Yeah.
How do you think that kind of like overlaps, like when you're just trying to like get mechanics, something like the paddle where you're doing the squash and stretch, but you're trying to like figure out collision and different things like that.
Mm-hmm.
Like at what point do you kind of go like, okay, well, better like add this in? I guess kind of like a polish.
Sure. Yeah. So the question is like, when do you switch to juice, or when do you start juicing versus when do you implement mechanics or implement like physics or whatever, right?
Yeah,
Like
if you're
core.
trying something being more like mechanics focused too.
Right. Right. The way I see it is I don't like to really make games that I don't think I can make in a few hours anyways, like at least starting prototypes. So I get the core thing, the core vision down, or the core like experience down, or mechanic or whatever it is, right? So for example, I made a prototype called Car Golf where I was just like, it's mini golf except with a car that has a tank of gas. So it just goes infinitely until it runs out of gas and then it stops, and that's how you putt, right? And so before I add juice, I'm going to implement click and drag to shoot a car, and then it bounces off of, maybe it has physics, it bounces off of walls, it bounces around, and it can go in a hole, and then now it's an opportunity to add some juice if I want. But it is kind of a process that is as you feel is a good step. Maybe it's, for you want to juice earlier than that. Or you want to add juice maybe a little bit after you get the core physics or whatever in, and then wait a little bit, keep working on it, play test it, and then say, oh, I want to pump up the juice for this play test. Like I know that I have an expo coming up and I want to show this game, pump up the juice in the weeks leading up to it. Because the nice thing about juice is often it doesn't introduce game-breaking bugs. So you can do stuff like add particle effects without worrying about totally destroying your game, right? So those are things that can be done last minute if you're coming up on like kind of a good opportunity to show it to the public. So it's really up to you. It's not like a hard rule, but for me personally, it's like get the very basic mechanic in first, very basic interaction, prototype that, and then add a layer of juice, and then keep working on what I feel like, play the game, play with it, kind of smush it around, and then see what comes out of that, where I think it should go from there. Cool. Well, thanks so much. Like I said, I'm going to post the slides, and they'll be linked to the project and to all of the resources, which I definitely recommend checking out.
Thanks, Noah.
Yep.